Hello and welcome to API Versioning, a part of the Building APIs with ASP.NET Core course. In this module, we'll talk about how to increment the functionality of your APIs without breaking users across the board. My name is Kevin Griffin. I'm an independent software consultant and 10-time Microsoft MVP, focused in ASP.NET development and deploying solutions to Microsoft Azure. It is my pleasure to teach you how to build APIs with ASP.NET Core. In this module, we're going to talk intensively about versioning. More specifically, we'll discuss why you would want to version your API, and we'll talk through the process of adding versioning features to ASP.NET Core. In this section, we'll discuss why versioning is even a topic that needs to be discussed, and why you should consider it for your APIs. The discussion of versioning starts with the basic understanding that APIs are contracts for other applications. Much in the same way we create interfaces for objects in C#. When you build an API, you're telling consumers of that API that you guarantee that certain endpoints will be available. And you expect those endpoints to take certain parameters, and you expect those endpoints to return certain types of data in certain formats. If someone builds on your API and then 3 months later you change a critical piece, it will break for anyone that was using it. How would you like it if software that's been running fine for months just stopped working because of an issue with external dependencies? Of course, this conversation is based off of public-facing APIs. If you're developing an API just for your purposes, then the reasoning to use APIs diminishes greatly because you can just couple application versions with an implementation of the API. But if you're building a public-facing website, it's wise to consider how you'll version it from the very beginning. How about a non-code example? This is a picture of my 1999 Ford Ranger that I bought when I was in high school. I still own this truck today and I take amazing care of it. But as the truck ages, parts for it are a bit difficult to find. When I go to the parts store, I might need to specifically say that I have a 1999 Ford Ranger. And maybe even then I need to say the size of the engine or the trim package that I bought. Automobiles are a lot like APIs. They're built with a certain set of tools and interfaces in mind. Here's a picture of the next generation Ford Ranger that was released 20 years after mine was built. The name is the same, and I can guarantee that the stuff under the hood is different. APIs work much the same way. You'll want to build and improve it over time, and things will change. But folks that are using your APIs from months or years ago might not be ready to make the move to the next generation. Ensure that they have access to what they had access to. Now, we're going to discuss 3 separate ways to version APIs. The first is going to be via the URI or the URL. The second is going to be via the query string that you can attach to the end of the URL. And the third is going to be via headers. URI versioning is commonly used when you want to express the version of an API in the actual URL of the API. The example on the screen demonstrates. Typically with this approach, you have to designate versions no matter what, and that prevents people from just using the latest version of the API by default. Query strings are often used for designating version numbers as well. A nice feature of query strings is that it can just be optional, and the latest version of the API would be used by default. And finally, the last common way of designating versions is through a header. As with query strings, this can be optional, and a default latest version of the API would be used. No matter which method you or your team decide to use, ASP.NET Core is ready to accept your configuration and handle the details for you. In this section, we're going to talk about the steps necessary to add API versioning support to our ASP.NET Core APIs. Unlike most of the modules in this course, API versioning is not a core component of the ASP.NET Core stack. You'll need to install a separate package to add this functionality. That package is Microsoft.ASP.NET Core.MVC.versioning. There are multiple versions of this package that target older ASP.NET Framework applications and versions that have additional functionality for OData. In the examples we're working with, this is the particular package you'll want to install, although the version might be higher. Adding API versioning starts in our startup.cs, where we'll add services.addAPI to our configure services method. And there are two overloads of this. First is the default, and the second is where you're able to configure some of the options yourself. We'll talk through a couple of the things that you might want to override. The first step of setting up our configuration is to tell ASP.NET Core what the default API version should be. This is done via a configuration property off of the addAPI versioning method. In particular, we'll want to set the default API version property and tell it what version we like to use. As discussed earlier, there are three methods for defining how version numbers are determined from a request. The API version reader property lets you set a particular type of reader based off how you want to interpret version numbers. The query string API version reader, you guessed it, reads versions from the query string. Not only that, you can designate multiple names for the version. In our example, we'll respond to version, ver, or just v. Headers can be used by providing a header API version reader instance instead. This can also take multiple names. Lastly, if you choose to use URL segments, this is done via the URL segment API version reader. No parameters necessary. But since there's no configuration, you'll need to add an API version raw parameter to your controllers or actions that use different API versions. Now, typically, this method isn't recommended. You'll spend a lot of time configuring your API versions instead of just building your applications. As you build out multiple versions of your application, you'll start to wonder how you can set the versions of controllers or actions. First, you'll use the API version attribute or decorator on any controller or action you need to control the version of. As you can see here, I have two product controllers, each with a different naming structure, but they're pointing to different versions. The routes for each controller are the same. So the API will determine the appropriate course of action solely based off the version requested by the client. Now let's walk through a couple scenarios of adding API versioning to our applications. In this demo, we'll walk through a couple examples of how we add versioning to our ASP.NET Core APIs. Here we are back in our products controller, and we want to get started with adding API versioning to this particular application. I've already taken the liberty of adding the ASP.NET Core versioning package. And to set everything up initially, I need to go into my startup.cs file, and we need to add the dependency injection for API versioning. This is done with add API versioning on the configure services method. And now we want to walk through setting up the initial versions for a couple of our endpoints. Over in the product controller, what I like to do is set up the initial API version for this method, get products, because I'd like to go add a new version of it that takes some additional parameters, but I don't want to break this functionality by not adding certain features. And this is done by adding the API version attribute, and you give it a version number. So I'm going to call this 1.0. And it's important to note you can do this on either the action or you can do it on the controller. It's up to you and however you're versioning your applications. In this particular example, I'm just going to version this one method because my other methods are just going to be the single version until I have a reason to version them otherwise. Now, if only it was this simple to get started. I wish it was, but it's not. Let's go into our startup CS and add a little bit of new configuration. Inside of add API versioning, we're going to set a couple of options. The first option that we're going to set is the default API version. And we're going to just use 1.0 because that's the current version that we're supporting. We're also going to set another option to assume the default version when unspecified. And this will be set to true. The primary reason we want to set this option is that there are going to be cases where a request might not have a version number attached to it. And it makes sense when there's no version specified in the request. We should just assume the current latest version of our API. Now, since products controller has a version designated on it, let's go ahead and run this example to show you what happens. I've set this request up in Postman and I will hit send. And it will come back as a 200 OK and have all my data inside of it. Now let's take a moment and go add a new version of this particular request, one that might take a query string with some additional filtering. Back in the products controller, I'm going to create a new version of get products. And this one isn't going to be too much different with the exception of it's going to take a query string just called filter. The slight change that I made is I added another API version attribute. I've changed that version to 1.1 versus 1.0. But both requests have the exact same API URL. In normal circumstances, these would actually throw an error during runtime because they both match the same URL endpoint. But because I'm using API versioning is going to kick in and help determine which one should get used. And because get products with the API version of 1.1 is the latest version of the API, it will take precedence. I also need to make sure that over in startup.cs, I changed the default API version to 1.1. And just for fun, I'm going to show you another option in add API versioning where we can tell the API to report what versions of a particular endpoint exist. And this can help for debugging or just general help in development mode. So again, I have get products and also get products version 1, version 1.1. We'll run this example again. We'll come back into Postman and I'll hit send. And you'll see that it really doesn't make much of a difference. To show you that this is working the way that we anticipate, I'm going to set breakpoints on both line 23 and 32. We'll hit send, and you can see API 1.1 is the endpoint that actually gets executed. Back over Postman, we'll look at the headers for this request response. And we'll see there is a header that is called API supported versions. And this includes both version 1.0 and 1.1, telling us that we can designate between the two versions however we wish. Well, let's talk about now, how do we swap between the different versions based off the request coming in? And we have three ways available to us to handle this. We have query strings, we have headers, and we also have the URL itself. So let's walk through those three processes and show you an example of each. Back in add API versioning, I'm going to add an API version reader for query strings. And this particular reader takes a couple properties. I'm setting different names for the version that we want to designate. When this is done in production, what should happen is we'll get the request to localhost API products with a query string version, and this will be 1.0 or it could be 1.1. We still have our breakpoint set on the two actions. I'm going to run this again. We'll come back in the Postman, and this time I'm going to set a query parameter for version. And instead of 1.1, which we already know is the default and it's what would get used, I'm going to set the version to 1.0, the older version of that API call. I will hit send, and we'll see that the 1.0 version of the endpoint is executed. But just for fun, what happens if you put an invalid version in the version number? I'll set this to 1.5, which is not defined in our application. Well, since ASP.NET Core doesn't recognize the version that we requested, it's going to tell us that we sent a bad request. And the error is that the HTTP resource that matches our URI doesn't support the API version 1.5. Now, this is only because we specifically gave a version number. If we were to remove version altogether, it would use the default version number. Now let's use a version reader that uses headers instead of query strings. And this is done with the header API version reader. And for the parameters of this particular object, you define the header name. I'm going to use x-version as my header name, but you can use whatever you'd like. Back in Postman, I have the request set up again. This time we will go to headers, and I'm going to add a new header for X version, and we're going to define this as 1.0. If I press send, ASP.NET Core detected it was a 1.0 version that we requested. It will automatically pull the correct action, and we get the response that we expect. Now, just as before, if we were to put in a version that did not exist, the same error would apply, that we requested a resource that did not support the version 1.9. Last but not least, the final way that we can support versioning in our requests is via the URI. This is my least favorite way to do it because it's a little bit harder to support, and I don't think it's as flexible as the other two versions, but I'd like to show it to you just for completeness. We'll add a new API version reader for URL segment API version reader, and this version reader requires an update to our routing. In our controller, we have to go up to the top, and in our route for our API/products URL, I'm going to add a placeholder here for version API version/products. This means for any request that comes in, the entire API route has to change. So just as an example, this new URL is API/1.1/products. Let's run this example one more time. I've reset my URL in Postman. So this is a completely empty basic request. Now I'll leave the URL alone. We won't put anything in there. And I'll hit send. And this time I get back a 404 not found because the URL does not match. Because I've had to change the URL structure, it's not possible for me to use default APIs now. But that's okay, because in my route, I'm going to type in 1.0/products. If I hit send, it hits the breakpoint of the appropriate action, and I get back the results that I expect. And you might be asking yourself, Kevin, how do I support a default API version with this particular method? Because I don't want to force the user to put a version into the URL. Well, don't forget that routes are stackable. We can define multiple routes, and that's what I'm going to do. We'll say API/products, and then I'll also have the version of the route that has a version inside of it. This way, if I take the original request with no version, the endpoint knows that my default API version is 1.1 and not 1.0. It will automatically point to the correct action, and the results come back as I expect. And one little tidbit, if for some reason you want to use multiple methods, I really like both the query string and the header approach. What if I want to use both? Well, there's a method for that. Instead of defining just one API reader, I can use a special method called combine on the API version reader object. This allows me to pass in multiple API version readers, and ASP.NET Core will automatically use one or the other depending on the request that's coming in. Now, before we wrap up, let's talk about another fun example. I'm going to run this application one more time. I'll start with a blank request in Postman. We'll add a query string for a version and set that to 1.0. But I will also go to headers and create a header for X version and set that to 1.1. Effectively, I'm creating competing requests, 1.1 versus 1.0. Take a moment and just talk to yourself. Which one do you think is going to win? Well, if I hit send, I get back an error message of 400 bad request because I, as the client, made a improper request. And this response tells me that the following API versions were requested: 1.0 and 1.1, but it's only able to choose one result. So I need to update my request and try it again with a better version number. So there you go. That prevents you from accidentally coding yourself into a hole, and it prevents your code from having to guess which one of the versions it should use. Send back proper error codes and everything will be great. So there you go. That is API versioning in a nutshell. Good luck and have fun. In this module, we discussed why versioning is important. It helps public APIs from breaking functionality for existing users and allows you to continue development forward. The API versioning libraries of ASP.NET Core are opt-in, and they have to be installed separately. But once they're installed, these libraries decorate existing controllers and actions to add versioning elements. Thanks for listening to the API versioning module, part of Building APIs with ASP.NET Core course. My name is Kevin Griffin.